Greetings, this is N1IR, and this is part 5 of the Tech Frequencies Q&A. Let's begin. What does the abbreviation RF refer to? Radio frequency signals of all type. What type of wave carries radio signals between transmitting and receiving stations? Electromagnetic. What are the two components of a radio wave? Electric and magnetic fields. How fast does a radio wave travel through free space? At the speed of light. What is the approximate velocity of a radio wave as it travels through free space? 300 million meters per second. What term describes the number of times per second that an alternating current reverses direction? Frequency. What is the unit of frequency? Hertz. If the frequency readout calibrated in megahertz shows a reading of 3.525 megahertz, what would it show if it was calibrated in kilohertz? 3,525 kilohertz. What is the name for the distance a radio wave travels during one complete cycle? The wavelength. What property of a radio wave is often used to identify the different frequency bands? The approximate wavelength. How does the wavelength of a radio wave relate to its frequency? The wavelength gets shorter as the frequency increases. The wavelength gets longer as frequency decreases. What is the formula for converting frequency to the approximate wavelength in meters? Wavelength in meters is equal to 300 divided by frequency in megahertz. What is the frequency referred to as HF? 3 to 30 megahertz. What are the frequency limits of the VHF spectrum? 30 to 300 megahertz. What are the frequency limits of UHF spectrum? 300 to 3000 megahertz, or 300 to 3 gigahertz. What frequency is within the 6 meter band? So with this question, we can use our calculator really quick. We take our speed of light divided by frequency, and that will give us the wavelength. So the first answer is 49 megahertz. That's 6.1. Let's try 300 divided by 52.525. 5.7. So this is the correct answer, B. 52.52. Again, it's the approximate wavelength that we're looking for. Which amateur band if your station is transmitting on 146.52? So let's go back to our calculator again. 300 divided by 146.52 gives us 2.04 meters. So A, 2 meter band. Which bands above 30 megahertz that are available to technician class operators have mode restriction subbands? That's going to be your 6 meter, your 2 meter, and your 1 1/4 meter bands. They all have mode restricted subbands. What emission modes are permitted between 144 and 144.1 and 50 to 50.1 megahertz? That's CW only. What amateur band are you using if you're transmitting on 223.50? So let's go back to our calculator real quick. 300 divided by 223.50 gives us 1.34, which is about 1 1/4 meter, right? So 1 1/4 meter band. What emissions may be used between 219 and 220 megahertz? Data. Which 70 centimeter frequencies is authorized for a technician class holder operating in ITU region 2? 443.53. Notice A is 6 meter, B is 2 meter, D is 1 1/4 meter. So all those answers can get tossed out, and the remaining one is your 70 centimeter frequency. What is the national calling frequency for 70 centimeter? Again, A and B are way off. C is kind of close, but it's going to be D, 446.000. Which 23 centimeter bands is authorized for the technician class operator license? Again, you can take your calculator out and figure out what frequency is on 23 centimeters, and we know it's 1296. These other answers are not even close. What must you do if you're operating in a 23 centimeter band and you learn that you're interfering with a radio location outside the United States? Stop operating and take steps to eliminate harmful interference. What is a band plan? Beyond the privileges established by the FCC. A band plan is a voluntary guideline for using different modes or activities within the amateur band. Which of the following is the result of the fact that amateur service is secondary in some portions of the 100 centimeter band? U.S. amateurs may find non-amateur station in the band and must avoid interfering with them. Why should you not set your transmitter frequency to be exactly on the edge of the amateur bands or the subbands? All these choices are correct. It's to allow for the calibration error in the transmitter frequency display. It's so that the modulation sidebands do not extend beyond the band edge, and also to allow the transmitter frequency to drift. So all those questions, all those answers are correct. So it's going to be D. All these choices are correct. And that is the end of the Q&A session for Section 5. See you in the next one.